today on how it's made. Escalator handrails. We'll get things moving with the details of how they make them. Highlighter pens. This one's a real attention getter. Guitar strings. Making them is a finely tuned process. Wigs. We'll have the long and the short of it. The escalator was invented over 100 years ago as an amusement park ride. The moving staircase was soon equipped with a moving handrail for safety reasons. But those early handrails were driven by oily chains, leaving passengers with greasy hands. We get a cleaner ride on today's escalators, and if we want thrills, we try a roller coaster. Going up, hold on to the handrail. It moves at the same speed as the stairs beneath you, making your ride safe. To make an escalator handrail, a machine called an extruder pulls synthetic rubber up into it. A turning screw inside the extruder forces the rubber through a die, the way a pasta maker squeezes out spaghetti. 10 to 15 centimeter wide rubber strips roll out into a tank of water to cool because the heat from the extruder could alter their molecular structure. Now the rubber strips move over rollers that are part of a mechanical measuring system. There's a little indicator on the roller that gauges the width and thickness of the rubber as it moves across. Over at the splitter machine, small round knives slice rubberized cotton the same width as the rubber strips. Then a mechanical puller unrolls material from 4 different spools. There are 2 streams of rubberized fabric, 1 stream of the synthetic rubber, which came out of the extruder earlier, and 1 of rubberized cable wiring. They merge and stick together as they travel over a big steel roller. An unwinder peels away a plastic liner from the now 4-plied strip. Next, a worker places a piece of rubberized fabric and 1 of synthetic rubber on either side of the 4-plied strip. He presses everything except the strip of rubber around a U-shaped aluminum former. With a piece of steel, he bears down on the shape so the layers stick together. Then he brushes tack cement on the outside and pulls that piece of synthetic rubber at the bottom up around it. He folds the rim down, and using a hand roller, he seals its edges. Now the handrail has taken shape, but it's not strong enough. So a worker places it in a molding press. He positions a steel form inside the handrail so that it holds its shape. The top part of the mold lowers, and the handrail bakes under high pressure at 180 degrees Celsius. 10 to 15 minutes later, the mold lifts, and a chemical reaction called vulcanization has occurred. The layers have been laminated, and the handrail is now strong enough. The last step is to trim away the flash or excess material. Here's the latest way to make an escalator handrail. A puller unwinds brass-coated steel wires from spools, drawing them, along with thermoplastic urethane and polyester fabric, through the dies of an extruder. What comes out is a strip of plastic-encased wires and sliders. The handrail shape passes through measuring devices that check its dimensions. Now they splice the ends of 2 plastic handrails together to form an endless loop. Using a roller, a worker presses the wires and plastic sliders of the inner carcass together. As he rolls, he blasts hot air into the splice with a heat gun. This softens the plastic so that it melds together. He covers it with a piece of thermoplastic urethane and again uses a heat gun to join the pieces. He wipes it clean with alcohol. Then he heats it up in a mold for a minute or 2. The spliced section melts together and then cool water hardens it. There's no seam line where the handrail loop could break. That's to say, no loopholes that could cause any trouble. And that's the inside story on the Escalator handrail. Something to think about when you're on your way up. The highlighter pen was invented in the 1960s simply to get your attention. When text is shaded with transparent vivid inks in hot pinks or warm yellows, our eye goes directly to it. Marketers have always known that color has impact, and it's a principle highlighted by these pens. Shades of neon. When it comes to highlighter pens, drab colors are a write-off. This is how a highlighter pen gets its start. A vacuum siphons plastic pellets into this container. The red ones will tint the whole mix as it melts inside a heating tube. A mechanized steel screw pushes the melted plastic into pen molds. The force applied is equal to the weight of 350 elephants. Cooled by water, the newly molded pen barrels spill into a container below. Now, some clear-colored pen barrels drop onto a conveyor track. And ink reservoirs that look like pieces of chalk but are made of polyester drop down a shaft, and a robotic arm thrusts them into the plastic barrels. The back-end plug goes in the same way. The plugs fall to a robotic arm and it pushes them into the back of the pen. Now a chemist drops a concentrate of dye into a beaker of water. Just 10 grams or drops is enough to turn it fire engine red. A humectant already in the water will keep the ink from drying out when it's in the pen. Next he measures the ink's thickness. He lowers a steel probe into it and the probe turns. A gauge measures the speed. If the probe turns too fast, it means the ink is too thin. If it revolves too slowly, then the mix is too thick. At 4 revolutions per minute, the ink is just the right consistency. A vacuum pump sucks the ink into 6-inch steel needles, and a robotic arm pushes the needles into the polyester reservoirs, injecting them with ink. Now we get to the nib of the assembly. A combination of mechanical vibrations and compressed air drive a conveyor belt carrying the pen nibs. The nibs fall into the clutch of a mechanical claw, which drops them to a circular pusher. It shoves the nibs onto the pens and they interlock. The impact floods the reservoir inside the pen with ink. Now it's time to top it all off. A conveyor transports caps to a mechanical gripper, and the gripper slides them over the nibs. Over on another assembly line, they're making a 3-in-1 marker. A conveyor bowl funnels smaller ink reservoirs into a shaft, and they drop to a robotic arm. The arm stuffs the reservoirs into the small barrels, and then a needle injects them with ink, quickly saturating the reservoirs with vibrant color. The next robotic arm shoves a receptacle onto the barrel, and then another robot presses a polyester nib onto it. A robot now slips a hood-like cap over the nib. Another mechanical arm suctions up the fuchsia-colored mini markers and transfers them to a triangular case. Down the line, another suctioning arm picks up a red mini marker and deposits it in the triangle. A steel probe presses it in. Finally, a yellow-colored marker completes the triangle. Now a robot uses an electrical charge to pick up metallic confetti. When the charge is turned off, the confetti drops into the triangle, adding some glitter. Next, a suctioning robot drops the top part of the triangle onto the lower case, and a metal cylinder presses it shut. Another suctioning arm carries the 3-in-1 marker to a conveyor belt, which unloads it into a box. This 3-in-1 highlighter makes it easier to color code text, a different color for each theme. Now, an electrical conveyor moves the highlighters to a mechanical arm. The arm flips it around, positioning it for the next step. A squeegee silk screens a logo onto it. I wonder how they came up with that one. Now the highlighters enter an ultraviolet light chamber. The light bonds the ink to the case. And finally, the ultimate test. Plastic grippers guide markers as they make circles. 700 to 1,000 circles means this particular production line will definitely stand out. Playing the guitar is really all about giving good vibes to the audience. The guitar uses vibrating strings to generate tones. Strings under tension vibrate at a specific frequency or pitch. So if you're feeling good vibes from that song on the radio, it may be because of those guitar strings. A good set of strings is behind many a soulful tune. Strings are center stage when it comes to a guitar's sound. To make a guitar string, they start with a steel core wire that they examine under a zoom stereo microscope. They magnify it 100 times, looking for flaws in the hexagonal wire. Next, they measure the core wire's diameter with a digital micrometer. It has to be just the right size. Now they coil the wrap wire made of nickel-plated steel around posts on the Instron testing machine. This machine stretches the wire until it breaks. It's a test of its ability to perform under tension. A computer measures the distance and the amount of load the wire was under before it broke to determine how much tension this string can take. Now the core wire undergoes a twist test. They loop the wire onto a hook in a machine called a torsion tester. It spins rapidly, twisting the core wire until it breaks. This is a test of the wire's strength and elasticity. These plastic hoppers are full of ball ends. This machine is called a ball end sorter. Hollow pistons move up and down, selecting one ball end at a time. This ensures that only those of the proper size will get through. The ball ends shoot out of the pistons into a bucket underneath. From here, they'll go to the core string machine. A mechanism places the ball ends on a pin as they drop from a hopper. Rollers feed the core wire into a clamping guide, which aligns it with the ball end. Then the pin spins, twisting the wire into a neat loop around the ball end. This is the twisting action in slow motion. The core strings with the ball ends now attached drop into a repository. Then a worker hooks a ball end with its core wire onto the string winder, and he loops bronze wrap wire around the core wire. A string winding carriage guides the bronze wire down the length of the core wire as it wraps around. The electrically powered winder spins the core wire, and it's that action that grabs the wrap wire as the carriage ensures that it gets wrapped neatly. Computerized sensors monitor the speed that the string is wound at, as well as the tension. The winder applies a critical amount of tension as it wraps the bronze wiring around the core. And it's a wrap. They're bundled up like straw, 144 wires to the bunch. Guitar strings are also made from nylon. They hook the nylon core material onto a winder, pulling it down from a big spool. Next, they loop silver-plated copper wrap wire onto the nylon. The hook spins, and this coils the wrap wire around the nylon string, binding it. Again, a carriage system run by an electric motor ensures that everything falls into place. A worker removes the strings and hangs them on a rack. Gravity causes the strings to slide down into a station where workers coil them and then place them on a conveyor belt. Further down the line, another worker puts them in a bag that has a gas-neutralizing barrier built into the plastic to prevent corrosion. And now, these strings are ready for some good vibrations. Throughout history, wigs were status symbols, hence the term bigwig. One early wig-making technique was to use goat skin to simulate a scalp and then hook hair into it with an embroidery needle. Today, animal skin is no longer used, but some bigwigs still wear hairpieces. These days, your crowning glory could be synthetic, but it can look so real, it'll turn heads. To make a custom wig, a wig master measures the client's head from all angles because heads come in many shapes and sizes. He wraps her head in cellophane, twisting it just under the earlobes. Next, he sticks filament tape all over the cellophane wrap. He layers it 4 times to make a cast. He lifts the tape and cellophane cast from her head and places it on a wig block, a head shape made of canvas or wood. Using a grease pencil, he traces around the cast, making a pattern of the client's hairline on the wig block. The wig master then cuts pieces of plain blue paper. He pins it on the wig block within the pattern lines. The paper will prevent light from reflecting into his eyes as he works. Now he places a large-sized polyester and cotton lace on the block and cuts it to the penciled outline. He pins a finer lace from front to back, pleating the edges with pins. He pulls open a drawer full of real and fake hair, and it's hard to tell the difference between them. He chooses a tail of synthetic hair labeled Venetian blonde. Pieces of pink and orange synthetic hair will be blended into the Venetian blonde tresses to create dramatic highlights. This is the tool for the job. It's a giant comb with rows of sharp steel teeth. It's called a hackle. The wig master places the Venetian blonde synthetic hair between the teeth of the hackle and sets the bright pink and orange locks on top. Now he repeatedly drags the hair through the hackle. He loses some strands in the comb, but those are usually the weaker ones. This is called hackling, and the action gets progressively more vigorous. He twists and twirls the tail as he pulls it through the hackle. This is actually dangerous work. One wrong move, and he could pierce his hand on the barbed comb. Once the hair is blended, he cuts it in 2. Then he presses the hair into little metal pins on a leather holding card. The pins on a top card interlock with the bottom one. He pulls hair out of the holding cards a few strands at a time. With a small needle that looks like a fishing hook, he knots the strands into the lace, beginning at the nape. This is called ventilating. It's very similar to rug hooking. In fact, it may be why toupees are often referred to as rugs. Ventilating is labor-intensive. He spends a minimum of 50 hours knotting the thousands of strands that it takes to make a wig. Partway into the job, he combs out any tangles and flounces the hair to make sure it moves naturally. Wigs for film and TV are usually made by hand rather than machine because the result is more authentic looking. Because the camera tells all, the wigs need to look as real as possible. He weaves the front of the wig one strand at a time because the front hairline always gets the most scrutiny. Now it's time for the fitting and the transformation. The wig needs a little styling, and he trims the ends. He cuts away the extra lace, and voila! She's ready to let her synthetic hair down and get into her new role. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.